why do we look the way we look? Most of it's down to dear old planet Earth. Its atmosphere, gravity, that kind of stuff. When you go on a week-long beach getaway, you get a tan. Basic. But what about living on a whole other planet? One astronaut spent a whole year living on the International Space Station. Zero gravity means no healthy pressure on your body, so his bones got weaker. So did his muscles. It also gave him more space between his vertebrae, so he got a bit taller. And that's only a year. The more time you spend at the beach, the darker your tan gets. So, what if we move to Mars? The first major change you might notice, after a couple hundred years, is your brand new skeleton. Gravity on Mars is much lower than on Earth, so your muscles and bones would probably shrink. Not great for surviving on a new planet. Gravity would make us feel our weight differently. If you weighed 150 pounds on Earth, you'd only feel like you weighed about 50 pounds on Mars. You'd need to eat more to get stronger and bigger to make up for Mars's weak gravity. Sweet! Time to grow some larger and stronger bones, organs, muscles, everything. There'd be one more dramatic change. Your largest organ, your skin. It's the most important barrier that protects you from everything. Germs, wind, UV light, looking totally creepy, you name it, it does it. You might just need a whole new skin. How do you feel about orange? Sorry people, green skin is totally sci-fi. Here's the deal. Carotenoids offer quite a nice protection against UV light. That's the stuff you find in carrots, sweet potatoes, bell peppers, tomatoes, pumpkins. A Mars farmer's market could make a fortune. The more of these veggies you eat, the more orange your skin's gonna get. If you followed a special diet and wore high-tech gear, chances are, one day, living on Mars might be totally normal. Living on Mercury would be really tough. It's the closest planet to the Sun, and it's definitely hotter than Earth, but weirdly, not hotter than Venus. It's really hot during the day, about 800 degrees, but at night, it drops to -290. Days on Mercury are kind of crazy. You know, when you finish the day, but you didn't really get a lot done? Problem solved, move to Mercury. A day on this planet lasts about 58 Earth days. That means you'd have a lot of time to get ready for bed. My guess, though, you'd probably get kind of bored. One excellent solution. Somehow, become made of metal, like titanium, nickel, or platinum. Those guys can handle extreme conditions. Life on Venus would be way worse than Mercury or Mars. Pressure might be a tiny issue. You'd probably have one long, never-ending headache. Standing on Venus is like being 3,000 feet underwater. Oh, and that thing we need every moment of the day? Chocolate. Air? There's not a lot of that floating around on Venus. There's carbon dioxide everywhere, and the planet's surface is completely dry. That means it's gonna be hot. 870 degrees hot. There are a few species on Earth that can survive the boiling point of water, and maybe if they mutated somehow, they'd survive Venus's crazy heat. 266 degrees is the record so far, set by a species of microbes. So get ready for an epic body transformation. Want to live on Venus? You'd probably have to turn into a tiny microbe just to survive. Luckily, Venus's atmosphere has phosphine, which isn't great for humans, but microbes just love it. But since you're not a microbe, not yet anyway, you'd need to wear special gear to control the pressure and feed you air. It's not looking good. Maybe it'd be easier on Jupiter. Yeah! No. It's got no solid land. This planet's made of hydrogen and helium and is known as a gas giant. Unlike Saturn, you'd probably end up just floating around on it. It's like a giant cloud, and if you ever managed to land, it'd be like walking through a super thick fog. Temperatures fluctuate a lot here. It's freezing on the surface, and the atmosphere can be super hot below the surface. We don't really even know. If you lived on Jupiter, there'd be no spoken languages. The gas planet absorbs radio waves, so even if you could speak, no one would hear you anyway. And there'd be no music, so no dance parties. What's the point? People would have to communicate in sign language. Great! But it's not. The atmosphere on Jupiter is wild. All kinds of winds and gas clouds. You probably wouldn't even be able to see anything. So that's not gonna happen. Still, Jupiter is awesome to look at. It's so big that it can fit all the other planets in our solar system inside it, with room to spare. A trip to Saturn will set you back about a decade, and it'd be a big old waste of time. Saturn's mostly made up of layers of gas. It has no solid surface, so farming, building, or any other normal Earth activities are out of the question. Before landing on Saturn itself, you'd probably want to explore those iconic rings around it. You'd fail though, because the rings are made of millions of ice sprinkles floating in space. That's pretty hard to walk on. You might have thought that Saturn was going to be a good fit for you. Some layers of this gas giant sphere actually have quite a nice temperature. If you dive into Saturn, you'll get to a layer with liquid molecules and a cool 32 degrees. That's like northern Canada, Alaska, Sweden, except that you can't walk on it. Anyway, it's only one minor layer, and the rest of the planet is insanely cold. So I guess if you still want to live on Saturn, you've got some work to do. No biggie, you just gotta turn into a snowball or something. What about Uranus? Time is kinda weird on Uranus, so if you're out that way looking for a nice vacation spot, definitely choose this planet. A 2-week getaway on Earth lasts 3 years on Uranus. There's even a sea if you're up for a beach vacation. The only problem is that it's made of ammonia, that gross-smelling stuff they use for cleaning. But watch out where you land. If you get it wrong, you might end up spending a whole year without any sun. How would you change if you had to spend a whole year in the freezing dark Uranus winter? We'd need bigger eyes to see in the dark, plus more of that thicker skin to keep the cold out. We might even develop a new hearing system, like dolphins have. Neptune. It's another gas planet, but scientists think there's probably a dense core inside. If you took the plunge to live on Neptune, you'd probably turn into a space reptile or cosmic fish, endlessly floating around on the surface. Gravity on Neptune is just a little bit stronger than on Earth. Still, it'd be really hard to stay in one place. The wind there is super strong. You'd have to be much heavier to resist it. Time to eat again, woohoo! But this planet's really impossible to live on. Scientists don't even want to send another spacecraft there. Welcome to Pluto. Freezing cold, tiny, and super far away. Doesn't sound too exciting. It's even smaller than our moon. It would be so hard to stay on the planet. No more trampoline parks, people. You'd probably have to build yourself a huge machine that would spin you around, sort of a fake gravity machine. Still, you try spinning around all day, you'd need a brand new nervous system to avoid feeling queasy all the time. But Pluto's not all bad. There's a liquid water ocean beneath the surface, and ice mountains. If you got yourself a highly trained crew and a bunch of expensive gear, and regular supplies from Earth, nah, too much hassle. Spaghettification. Wonder if you can choose your own sauce? It's actually something you might experience if you ever tried to live in a black hole. It's the process of squeezing objects, like you, into long, thin cosmic strips. So, good news, you'll get much taller. Bad news, you'll be thinner than a single human hair.
Picture this. You've won a membership to a space gym. You get to travel around the solar system and work out. But gravity changes on different space bodies. So let's find out if you can get stronger elsewhere or if you should keep practicing on Earth. Your spaceship is approaching dwarf planet Pluto. It's getting chillier by the second. No wonder! The Sun is over 3.7 billion miles away. You must be glad you brought your thermal spacesuit along, right? To leave the spacecraft, Earthlings would need the help of a gravity machine, since gravity on Pluto is a mere 1/15th of that on Earth. Gravity is the force that pulls you toward the ground. The smaller the mass of a space body is, the weaker its gravity. So, on Pluto, you can't do any sports that involve running. If you did, you'd most likely fly away. You can try out elephant lifting, though. After all, you can't do it back on Earth. On Pluto, picking up an elephant weighing 2,000 pounds feels like lifting 120 pounds. The next stop is Neptune. It's over 30 times farther away from the Sun than Earth. The atmosphere there is dark and cold. You might get overwhelmed by the planet's gigantic size. It's called an ice giant for a reason. Maybe today you'll feel like doing some winter sports? To say Neptune exists in perpetual winter is an understatement. The average temperature on this planet is around minus 373 degrees Fahrenheit. But gravity here is only 10% stronger than that on Earth, so you don't feel much difference. This world doesn't have a solid surface, so you won't be able to leave the spacecraft. Is that an ice hockey rink I see? Grab your ice skates and your stick and get ready to outplay your fellow passengers. How about a quick pit stop on Uranus? This is another ice giant, and gravity here is 90% of that on Earth. You can do a few push-ups inside the spacecraft, as you won't be stepping outside. The slushy surface of the planet is made up of water, methane, and ammonia in its liquid form. There's no solid ground to walk on. But if you somehow found a way to go outside, you'd feel lighter than on Earth. If you weighed 100 pounds back home, it would be 90 pounds here. Can we call this a Uranian diet? When approaching Saturn, please mind its rings, which aren't actually rings. They consist of pieces of asteroids and meteors flying around the planet. Saturn's mass is so big that it attracts many other space bodies to its orbit. And right now, you're one of them. Time to get creative with your workout. You've scheduled a skydiving experience here. If you freefall in Saturn's atmosphere, you'll reach the speed of 30 miles per second. Don't forget to open your parachute. On second thought, though, you won't be able to touch the ground anyway. Saturn's surface is pure gas. Quick fun fact, once Saturn got in the way of the 10th planet forming in the solar system. The planet's debris, which partially makes up Saturn's rings now, could have blended into a planet, but it was pulled into Saturn's orbit instead. You're nearing Europa, one of Jupiter's moons. Gravity here is so weak you feel weightless. Let's say there's a rock climbing wall there. How about you give it a try? Usually, this sport requires a lot of physical strength, but here you'll only have to carry 13% of your weight. Your climb to the top will be easy peasy in these conditions. Entering Jupiter's atmosphere will feel like being inside a cloud. See that red spot in the bottom left corner? That's a storm twice the size of Earth that's been raging for hundreds of years. To have some fun here, why don't you do some jumping jacks? I'll count to 100. Ready, set, go. Gravity here is super strong. It's 2.5 times as powerful as gravity on Earth, so you'll probably get exhausted at the count of 30. Too bad. Uh-oh. Passengers aboard the spacecraft, fasten your seatbelts. You might experience some heavy turbulence. To travel from Jupiter to Mars, you'll have to move through an asteroid belt. Just in case you're worried your ship will bump into something, relax, there's a distance of 300,000 miles between asteroids. Let's stop at Ceres, the only dwarf planet in the asteroid belt. Gravity here will make you feel pretty strong. How about practicing some caber tossing? Cabers are heavy logs that can measure up to 20 feet long. The goal is to throw them as far as possible. Here, a 180-pound pole feels as if it weighs 5 pounds, which is, basically, the weight of a melon. Ready for the Ceres caper competition? Woohoo! Finally, Mars. Remember all those handstands you've always wanted to try? Well, here's the place to do them. Mars's gravity is about 2.5 times weaker than that on Earth, which means you'll probably be able to lift your own body weight without any difficulty. Since people keep trying to terraform Mars, opening a gym here doesn't sound like a bad idea, does it? Passengers and crew members, we're now beginning our descent to Phobos. It's one of Mars's moons. Gravity here is incredibly weak. If you've always dreamed of having superhuman strength, this is the place for you. You can work out here by, say, doing some artistic gymnastics. Start off with a cartwheel, then move on to tricks performed in the air. On Phobos, you can start doing triple back handsprings in no time. Ah, look! Earth is about to appear on the horizon. It sure looks majestic from here, but we won't stop there now. Instead, let's visit Earth's sister, Venus. It has almost the same mass as Earth, which means these planets have similar gravities. Now, Earthlings can't survive on Venus's surface because of the large amount of ammonia in its atmosphere. But let's imagine you could practice some outdoor sports there. Do you feel like trying bumper bubble soccer? That's when you dress yourself in a giant bubble ball vest and keep bumping into other players. People play this game on Earth. On Venus, with its slightly weaker gravity, it might be a little bit easier. But still, you have to consider you'll be wearing a 25-pound ball as a vest, kind of like a hamster back on Earth. Not to mention your outfit will restrict your arms and legs. It's a challenge, but it sounds fun to me. Moving on, if you land on the sunny side of Mercury, you'll experience scalding hot temperatures of 800 degrees Fahrenheit. If you're feeling tired after your space workout, a relaxing, steamy sauna will be just the thing. You'll feel like a brand new person by the time you arrive on the next planet. We'll fly as close to the Sun as we can so that you can have a taste of its gravity. The Sun's mass is huge. It's over 333,000 times the mass of Earth. And gravity here is extremely powerful. You'd have trouble lifting something as light as a bottle of water if you managed to step on the surface of the Sun. Too hot, you say? Well, I imagine it's a whole lot cooler if you come back at night. Haha, just kidding. On our way back home, we'll stop by the Moon. Our Earth's natural satellite. Walking on the surface of the Moon will feel like jumping. You'll be able to jump as far as 33 feet, so why not try some parkour? If you play basketball, scoring a point will be very difficult. But then you can jump higher than the hoop and do an epic slam dunk. And how about baseball? If you throw the ball upward, you'll probably never see it again. Finally, we land on Earth. Sorry to disappoint you, but you're not coming back with any superhuman strength. Even when you were lifting an elephant, gravity was helping you out a lot. It was a good trip, though. Don't you think so?
I hope you feel well rested, because I've got a tough task for you. Don't worry, it's fun. You're going to visit different planets of our solar system and try to run on each of them. Let's figure out where you can run the fastest and where you can barely walk. The fastest man on Earth, Usain Bolt, can run with an average speed of about 23 miles per hour, but his top speed is higher, up to 27 miles per hour. Sadly, we can't all be Usain Bolts. The average person runs at a speed of 6 to 8 miles per hour. But maybe there's a planet out there where you can beat the famous Jamaican sprinters' records. But first things first, what will affect your speed when you run on other planets? For one thing, gravity. Depending on how strong it is on the planet you visit, it'll influence your weight. And in most cases, the heavier you are, the more slowly you run. Plus, on all other planets in our solar system except Earth, you'll have to wear a bulky spacesuit. Without it, your chances of survival there are non-existent. And don't forget about extreme weather conditions on most planets. It's either freezing cold or boiling hot, or very, and I mean it, windy. Anyway, your amazing journey is about to begin. Buckle your seatbelt. The first planet on your itinerary is Mercury. As you sneak a peek at this world through the window of your spaceship, you notice that the planet looks eerily similar to the good old Moon. But just a few moments later, you realize it's just an illusion. All over the surface of Mercury, you see craters left by space rocks. This may make your task of running on this planet way harder. This and your bulky spacesuit. Duh. But you wouldn't survive on Mercury without this protection. The temperatures on the planet are extreme, 800 degrees Fahrenheit during the day and negative 290 degrees Fahrenheit at night. But there's one thing that can work in your favor on this unfriendly planet. Let's say you weigh 155 pounds on Earth. Then on Mercury, you'd weigh around 58 pounds, which means that despite your bulky spacesuit, you can move way faster than you do on Earth. And maybe your speed will even reach 13 miles per hour if you try really hard. The next planet on your itinerary is Venus, also called the Morning Star. While coming closer, you see a world very different from the bluish planet you might have seen in books. Before landing, you have to get through a super dense atmosphere made up of carbon dioxide. And while your spacecraft is descending, you're watching thick clouds of sulfuric acid pass by. Venus is often called Earth's twin because these two planets are of similar size and density. No wonder that on Venus, you weigh almost as much as you do on Earth, 140 pounds. So your weight is a bit smaller here, but don't forget about your spacesuit. And still, because of almost the same conditions on the two planets, you'd be able to run a bit faster than on Earth at around 8.5 miles per hour. Your first impression of Mars is that it's freezing cold. The average temperature here is about negative 80 degrees Fahrenheit. Even from afar, the planet looks reddish. Once you make your first step on the Martian surface, you understand why. The ground's covered with rusty-colored dust. The same fine dust is floating in the air around you. Wherever you look, you see golden, brown, tan, and even greenish hues. They depend on the minerals that make up the soil. The size of the dust layer varies from area to area, but in most places, it's around 7 feet thick. That can make running much more difficult. On Mars, your weight would be much smaller than on Earth, a mere 58 pounds. This will help you achieve an impressive speed of 12 miles per hour. Aren't you a champ? What's that on the horizon? It looks like a tornado. Is it a dust storm? Then it's time to make a run for it. Dust storms sometimes cover the entire planet, and you can even see the largest ones from Earth. And now you're facing a problem. You see, Jupiter, as well as Saturn, is a gas giant. This means that the largest planet in the solar system, and Jupiter is so large it could swallow 1,300 Earths, doesn't have any solid surface. Well, you'll just have to imagine what your running workout would look like if you could run on Jupiter. This planet has an atmosphere that consists of hydrogen and helium gas. During your descent, you admire thick brown, yellow, red, and white clouds. They make the planet look colorful and beautifully striped. On Jupiter, you'd weigh 390 pounds. You'd have to break a sweat to simply walk there, wearing your clumsy spacesuit. If you could step on the planet's surface, that is. If you tried to run there, your best result would probably be a speed of 1 or 2 miles per hour. To make matters worse, it's extremely windy on Jupiter, with the wind speeds ranging from 200 to 400 miles per hour. Do you see those rings? That's Saturn, another gas giant with no solid surface. This planet's made up of mostly hydrogen and helium, and its temperature and density change the deeper you go. If you decided to leave your spacecraft and step on Saturn's surface, you'd just fall into the planet. But from above, it looks as if Saturn does have a surface. The seemingly solid yellowish-brown sphere is surrounded by several layers of clouds. The visible outer layer is made up of ammonia clouds. Under them, there are hydrosulfide clouds, and the innermost layer is made up of clouds of water. Even though Saturn is a gas giant, your weight wouldn't be very different here, around 165 pounds. That's because the planet's gravity is similar to that of Earth. But because of the conditions on the planet, and your bulky spacesuit, you'd run a bit more slowly there, at a speed of about 4 miles per hour. Before leaving, you admire Saturn's most famous feature, awesome gray, beige, and tan rings. These groups of tiny ringlets are made of chunks of rock and ice. You also spot several of the 53 moons of Saturn. Oh, that's Titan, an icy world bigger than our moon and even Mercury. It's the second largest moon in the solar system. The next planet on your way is a blue-green ball of ice and gas. That's ice giant Uranus. It has this beautiful hue because the light from the sun gets reflected off the planet's surface. Uranus isn't solid. Hit the brakes! If your spacecraft doesn't manage to stop in time, it'll fly through the upper atmosphere and sink into the icy liquid center of the planet. I doubt you'll be able to conduct your running experiment here. So let's just imagine what it'd look like. On Uranus, your weight would be around 138 pounds, and against all odds, you could actually reach a good speed here, at least 8 miles per hour. If you didn't get caught in a hurricane, of course. Extreme storms occur on the planet in the summer when Uranus is heated the most. Then, hurricanes can spread for more than 6,000 miles. The furthest planet from the Sun, Neptune, is 4 times the size of Earth, but 17 times as heavy. The blue surface you see when approaching Neptune is actually a layer of swirling gas and permanent clouds. The planet's mantle is made up of water, ammonia, and methane ices. It's the closest thing Neptune has to a surface. And still, there isn't solid ground for you to walk on. So, once again, try to use your imagination. On Neptune, you'd weigh a bit more than you do on Earth, 174 pounds, but your running speed would be just a bit lower than on Earth, around 5 miles per hour. That's the end of your active adventure. Which planet did you like running on the most?
1.5 feet with the Earth's gravity. Verification complete. Now the simulation room will recreate Mercury.
It's so hot in here.
Yes, it's like standing next to a volcano. Your jump is 4 feet high. Now switch to Venus.
Wow, this place looks scary.
On the real Venus, everything is toxic.
I feel no difference.
Yes, the gravity here is almost the same as on Earth. Switch to the Moon. Gravity on the Moon is 10 times lighter than Earth's, 9 feet. The next one is Mars.
Huh? It's pretty comfortable here.
The gravity here is the same as on Mercury. 4 feet. Now, prepare for the struggle.
Huh? What do you...
There is no solid surface on Jupiter. Although Jupiter is a great deal larger in size, its surface gravity is just 2.4 times that of the surface gravity of Earth.
It's hard to even stand here.
Only half a foot. Got it. Switch to Saturn. There is no solid surface here either, but Saturn's gravity is almost the same as Earth's. Now Uranus.
It's so cold.
It's 5 times warmer here than on the real Uranus.
Seriously? My legs are numb.
1.7 feet. Gravity is slightly weaker than Earth's. That's Neptune for you. Your jumps are 1.3 feet high. Gravity is slightly stronger than Earth's.
Get me out of here.
Turn off the simulation.
Okay, picture this. In the not-too-distant future, you're heading out on a space vacation, and you need to decide which items are worth bringing along. But instead of checking the weather forecast, you open a gravity simulator. That's because you need to know how each object will behave on different planets. For instance, should you take this metal shovel with you or not? Well, according to your itinerary, it's going to be a long trip. You're planning to visit every planet in the solar system and even a few moons. But due to the difference in gravity on these space bodies, you're not sure how useful some of the objects you're going to bring along will be. Well, let's start with the basics. Tupperware. I don't know about other space travelers, but us Earthlings carry our Tupperware around everywhere we go. And still, if you were to transport it to, let's say Mercury, it would most likely fly away into the atmosphere. These plastic containers you use to keep your food are too light. And since the gravity on Mercury is 2.5 times weaker as gravity on Earth, well, maybe you'll have to fill your plastic containers up before taking them out of your spaceship to have a picnic. If a Tupperware container weighs about 0.5 pound on Earth, it'll weigh just 1/4 of that on Mercury. Now, if we add some bananas, a handful of baby carrots, and 2 watermelons, then it'll be safe to carry it out of your space vehicle. You'll just have some difficulty making it all fit in a standard-sized container. But wait! Before you do that, you should know that the atmospheric temperature on Mercury can reach up to 800 degrees Fahrenheit. This means that any plastic container will instantly melt as soon as it gets in contact with the air. It'll burn up all the food, too. You can probably try taking a titanium container, that will work, or just stick to astronaut food. Now, shall we say Venus? Okay, Venus. If you were to take the same empty container to Venus, it would behave similarly to how it does on Earth. This is because Venus is also known as our planet's twin. These two have much in common. For example, almost the same size and mass. And when the topic is gravity, the formula goes like this. The bigger the mass and the greater the density, the stronger the gravity. Venus's gravity is approximately 10% weaker than Earth's. So, yes, you may leave your spaceship with your container, empty or full, and enjoy a beautiful and scenic lunch on the surface of Venus. Now, you'll have to figure out a way to eat without taking your spacesuit off, though. The atmosphere of Venus is filled with sulfuric acid, which can irritate your nose and throat and cause difficulties in breathing. Or worse. Much worse. Now, you'll have to forget about taking anything too light outside on Phobos. A little hint for you, it's not a Greek island, not even Greek yogurt, although it's a cool name. It's actually one of Mars's moons. Here, even your spacecraft would need a little extra help to keep close to the ground. If it weighed as much as a school bus, any regular-sized person could pick it up with just one hand. This is because on Phobos, the inhabitants of Earth barely feel the weight of gravity. And be very careful when jumping around because one leap and you may fly straight into outer space.
Passengers on board the Voyager spaceship, please keep your arms and legs inside the vehicle at all times.
Well, you're approaching Jupiter, a gas giant. A never-ending storm is raging in its atmosphere. Plus, there's no solid surface there, which means no landing for you on this planet. If you look out the window, it might seem that you are moving through a giant cloud. But for the purpose of your experiment, it'll work just fine. Try throwing into the air that baseball you brought along in case you get bored of all the space travel. And measure the time it'll take the ball to hit the surface. If on Earth, the ball will fall at a speed of 32,174 feet per second. On Jupiter, the same ball will hit the ground at a speed 2.5 times greater than that. That's because Jupiter is more than 10 times as large as Earth and around 300 times as heavy as our blue planet. Now, if you move your spaceship just a little bit to the side, to one of Jupiter's moons, Europa, the situation will be completely different. Throwing a baseball in the air on Europa will mean never seeing it again. Gravity there is almost non-existent, which means that not only a baseball, but even a grown-up person can fly away any second. Now, on the other hand, if you decided to venture out of the spacecraft to explore Europa's gravitational field, why not try to lift the space vehicle itself? On Europa, a regular Earthling can easily lift up to 1,000 pounds, which is the equivalent of a full-size male moose. Or you can lift a pyramid-like formation of 9 regular people. The choice is yours. When approaching Saturn, be careful. While from afar, Saturn's rings look smooth and solid. From up close, you'll notice that they're made of chunks of ice and rocks floating in space. You won't want to have your spacecraft anywhere near those. There's also no solid surface on Saturn, which makes landing impossible. And the atmosphere is full of ammonia. Keep in mind that it's a pretty inhospitable environment for a human. Now, inside the spaceship, you find a collection of sci-fi books, enough to fill an entire bookshelf. Altogether, they must weigh around 400 pounds. Yep, that many books. And like someone with a superpower, you try to lift over 200 pounds of weight at a time. But guess what? You fail, because Saturn's gravity is too similar to that on Earth. Now, in case you got confused with all this gravity talk, when we're measuring gravity, we're speaking about the power of the force by which a planet or other space body pulls objects toward its center. So, if you need some help in organizing that sci-fi collection in alphabetical order, ask the crew to move the spaceship to a neighboring space body with a weaker gravitational pull, like Pluto. These days, it's not considered a planet anymore, just a dwarf planet and one of the furthest from the Sun's space bodies. You'll need an extra warm spacesuit to wear there. Pluto is freezing cold and has a tiny surface. It's smaller than Earth's moon. But it's a great place to test your strength. If on Earth it's kind of impossible for a regular person to lift an elephant, on Pluto you'll be able to pick up a baby elephant weighing around 265 pounds. Or even a medium-sized elephant that can be as heavy as 2,000 pounds. On your way back to Earth, you make a pit stop on Uranus. The coldest planet in our solar system has an average temperature of around minus 350 degrees Fahrenheit. So, if you attempt to get out of the spacecraft, you'll freeze mid-movement. Although gravity on Uranus is pretty similar to that on Earth, there's one thing that's very different: time. A 2-week getaway on Earth turns into a 3-year-long vacation on Uranus. Now, when you get sick of cold planets, you can travel back to warmer ones. Okay, now, Mars is definitely warmer than Uranus, but its average temperature is still about minus 81 degrees. On Earth, we only have such low temperatures at the South Pole during the winter. When you land on Mars, you'll start to feel light and strong at the same time. Mars's gravity is about 2.5 times weaker than that on Earth. So, in other words, you'll probably manage to lift your own body weight without any difficulty. So, all those handstands you've been dreaming of doing, you've found the place to fulfill your dream.
So, the Terra planet's location seems to be at these coordinates. Okay, let's go to outer space to see the situation. Is it me, or is something moving? Oh no, there's too many piranhas! Oh my, there's too many of them. Oh no, 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 no! Leave me alone! Wait, no! I have to get back to the ship! We need to find shelter, now! Just a little bit more. Huh. Now we need to push off in the direction of the ship. It seems they don't see me. Come on, come on! Come on, almost! Oh no, this is the end. No, no, go away! Huh? Huh. So you guys aren't as bad as people say?
The ground shakes and you hear a loud cracking sound. Oh no, the dome is failing. Everyone runs to their escape pods to evacuate. People are pushing and shoving. The Earth-like atmosphere in the dome is going to be compromised, and you'll be exposed to the thin elements on the surface of Mars. Everyone rushes to put their helmets on. The crack is getting bigger by the second, and people are panicking, trying to get on the escape shuttles as quickly as possible. In the chaos, they all jam into the wrong ships, and there isn't any room for you. Red warning lights begin to flash in the dome, and a voice rings out, telling everyone to put their helmets on. The Martian atmosphere is only minutes away from rushing in, and humans won't be able to breathe otherwise. This is just your luck. You only just arrived on Mars. As the ships zoom off into the distance, you wonder what you should do. You call out for help, but no one answers. Suddenly, a robot guide rolls up behind you, and you hear a faint noise coming from its speakers. It says, "No one can hear you because the atmosphere on Mars is so much less dense than on Earth. It also has a lot of carbon dioxide, which absorbs sound waves. Even if a loud concert was happening just 30 feet away, it would sound like it was miles away. Would you like me to assist you with anything?" You ask it for help, and it shows you a 3D layout of the entire dome. You can see a few other shuttle stations, so you decide to aim for them. Unfortunately, you're going to need to get to the opposite side of the dome to reach another shuttle station. Just as you begin to panic and wonder how you could get there, the robot transforms into a bike and tells you to hop on. You get in and cruise through the city, looking at all the empty buildings and streets. The crack is getting even bigger, and tiny pieces of the dome begin to fall from above, like snow. When you arrive at the other station, the last few people are boarding the only shuttle. You chase after them, desperately trying to get their attention. As you ding the bell on your bike, though, it barely makes any noise at all. Their ship pulls away before they can notice you. You ask why sounds aren't working, and the robot explains that you can barely hear high-pitched noises on Mars. The carbon dioxide makes high-pitched noises, like bells and chirping birds, almost impossible to hear. If only you were still on Earth, they might have noticed you. The robot tells you that there's one last chance to escape. He transforms into a tiny spaceship. You get in, and he flies through the crack in the dome out into space. It's going so fast that you should be back on Earth before long. Just as you're starting to relax and enjoy the sights of space, you see a red light flashing on the robot. You ask it what's wrong, but you get no response. Suddenly, you realize that you can't hear anything in space. Sound travels in waves, and it needs something to move through, like air or water. Space is a vacuum with no air, so you can't hear any sounds at all. The spaceship suddenly changes direction and blasts off away from Earth. You try to steer the robot in the right direction, but you can't figure out how to get its attention. The ship charts a flight all the way to Venus. As you get closer, the turbulence kicks in. Venus has winds faster than any tornado on Earth. You keep getting swept away, trying to find a safe space to land in. The robot manages to keep a steady course, despite the wind throwing it all over the place. You can already feel the heat through all the layers. Finally, the robot spots a small cave in the distance and attempts to land there. As soon as the robot touches ground, it morphs into a spacesuit you can wear, so you're safe in the extreme environment. Today's forecast in Venus? Heat. Extremely boiling temperatures all day and night. Expect clouds of sulfuric acid and gale-force winds. The atmosphere is mainly made up of carbon dioxide, so you can expect your voice to drop deeper too because of the planet's dense atmosphere. It's only the second planet closest to the Sun, but it's actually the hottest. Its atmosphere traps the heat from the Sun and keeps it around the planet. It's actually so hot on Venus that it could melt lead. If you were cruising by with the spaceship, the whole thing would melt in a matter of minutes. Luckily, you have this indestructible robot armor. You try to ask the robot how to get back, and your voice sounds crazy. Your vocal cords vibrate slower here than on Earth, which makes the pitch lower. But at the same time, the speed of sound on Venus is a lot faster, making it more squeaky. Then, the high carbon dioxide content in the air creates a weird effect that tricks your brain into thinking that the sound source is small. Overall, you sound something like a cartoon duck. You look out across the horizon and see many hills and mountains scattered across the plain. But the robot tells you that many of these are volcanoes. Venus actually has more volcanoes than any other planet in the solar system. Scientists discover more than 1,600 only on the surface, which could mean there are even more than that still undiscovered. Yeah, maybe being here all day isn't such a good idea, and not just because of the heat. A single day on Venus lasts 243 Earth days. In fact, a day on Venus is longer than a year, because it only takes 225 days for it to complete a rotation around the Sun. It's hard to understand each other, but you eventually manage. The robot tells you that it just got lost, and that you'll be back on Earth in no time. While walking around the cave, you realize that you're actually inside a volcano. You tell the robot to hurry up and get you back home before it erupts. It's clearly not very good at navigating space, though, because it's not long before you end up somewhere else. You're now on Titan, Saturn's largest moon. The moon is so large that it's even bigger than Mercury, the planet closest to the Sun. The spaceship arrives in the atmosphere, which feels and behaves similar to Earth's. The only noticeable difference is the orangey haze hanging in the air, which makes it a lot more difficult to see. As you descend towards the moon, the robot detects signs of cyanide gas all over the surface and fluffy clouds made out of iced methane. You land on a soft spot and set about trying to get the robot to take you back to the right place. At least this time you're not sweating. The robot transforms again and begins to scan the surroundings. The atmosphere is around 60% thicker than on Earth. Walking around feels like you're wading through maple syrup. There is a really high nitrogen content in the air, so things sound surprisingly similar to how they do on Earth. You tell the robot you really want to get home now, but it comes out as a loud, raspy shout. This is because Titan has more nitrogen than Earth, and because sound travels a bit slower. Luckily, you can still understand each other here. The robot tells you that it needs to absorb a bit more energy from its solar panels before taking off, so you have a look around. This moon is one of the only things in the solar system that has fixed bodies of liquid like rivers, lakes, and seas on its surface. You can understand why the robot got lost now, given how similar Titan is to Earth. Titan even has liquid cycles, with rain, evaporation, and condensation. This isn't water like back on Earth, though. The main liquid here is methane. Scientists think that there may be volcanic activity, but instead of molten hot lava spewing out, it's water. Other planets, like Mars, have ice on the peaks of their mountains and evidence of water beneath the surface, but nothing is as close to Earth as Titan. Some scientists believe that this moon could be our next home billions of years from now. The sun's temperature will increase by then, making the Earth's atmosphere uninhabitable. By then, Titan's cool temperatures will be good enough to create stable oceans and sustain life. The robot finally gathers enough electricity to fly away, so you can head home. It'll be nice to have a normal conversation where your voice doesn't sound like an exaggerated cartoon. Whew.
You're strapped in a spaceship that'll take you all the way to Pluto for your galaxy backpacking trip. It's the longest journey from Earth, and without any shortcuts, so you'll have to get quite comfy. It's recommended for everyone aboard to have at least 8 hours of sleep at night. Astronauts in the International Space Station have little rooms suitable for one person with special sleeping bags and enough room for personal belongings. If they don't, they'll float, bumping into each other. It's a good thing the journey to Pluto will only take you a few days, so you can manage to have your full 8 hours of sleep for the rest of the trip. After a few days, you finally arrive at Pluto, and a bus takes you to the hotel. The dwarf planet is one of the darkest places in the solar system, reflecting very little light since it's located far away from the sun. You look out the window and see some decent landscapes with mountain ranges around 10,000 feet high. But instead of your snowy peaks like in Switzerland, it's methane ice. You have a smartwatch that can tell you the atmosphere characteristics outside. Pluto is filled with nitrogen and methane. After a couple of hours, you finally make it to the hotel and check into your room. You're surprised that you booked 1 day only. One of the first things you'll notice is the weak gravity, which makes it pretty hard to sleep. Then, finally, after enjoying a full day, you're ready to hit the sack. But the day isn't technically over. A solar day, when the planet rotates around its own axis, needs around 6 Earth days. So your 12 hours of fun and exploration was like enjoying just an hour on Earth. If you think that's long, then don't bother waiting 248 years to celebrate New Year's. That's the time Pluto needs to orbit the Sun fully. After a while, your biological clock adjusts to conditions on Pluto, so you end up sleeping for more than 72 hours to feel fully refreshed. You check out the next day, Pluto's next day, and fly off to Neptune. This magnificent blue planet may seem appealing, but it's extremely dangerous. But why not? You like the adventure. You get a fantastic view of all the 14 moons of Neptune while waiting for room service. You're somewhat jet-lagged and decide to sleep for a few hours. Even though you chose to take a nap, you end up wasting the whole day doing nothing but nibbling on snacks in the buffet. A day lasts around 17 Earth hours. You were able to fall asleep and slept for about 10 hours, which is more than half a day. And just like Pluto, it takes more than 100 years for it to orbit the Sun, 165 Earth years to be exact. After a while, you adjust your sleeping habits to just around 3 hours to enjoy the rest of your trip. You arrive at the largest planet in our solar system, Jupiter. After landing, you have to commute for another whole month before you come to your hotel. Don't worry, a full day is only about 10 hours. You check in and decide to stay in the hotel. It's not easy to go out since the weather is stormy. One of your programs includes a trip to the Great Red Spot, an area that's been tormented with hurricane-like storms for the past 300 years. The whole spot is twice the size of Earth. Jupiter could easily fit in 1,300 Earths. After a long couple of days enjoying the sights, you get back to the hotel and sleep it off. Since 10 hours is a full day, you're pretty tired and sleep off the entire day. But you couldn't get a proper good night's rest since the gravity is stronger than Earth's. Also, it wasn't easy going to the bathroom in the middle of the night. Eventually, you got your 2 hours of sleep adjusting to Jupiter's conditions. Mars is a lot more scenic than the rest. You book a full day at Olympus Mons volcano, which happens to be the highest mountain in the solar system. It's 3 times bigger than Everest. Your hotel has a beautiful view of the mountain and is also the most luxurious and advanced one you've ever booked. The day is 25 hours long, quite similar to Earth's. It means you can get your regular 8 hours of sleep. Sadly, outside the dome, there's a mega dust storm that's covering the entire planet. As soon as it settles, you take a trip to the polar caps, which are covered in carbon dioxide snow caps. You can feel the temperature drop. Even though Mars is the red planet, it's pretty cold. It needs 687 days to orbit the sun. Your body is starting to feel the changes moving from planet to planet. In many places, you couldn't sleep well or slept in what appears to be an entire day, even though it was regular for you. On Mercury, you check in at an underground hotel that looks like an ant colony and immediately feel the heat coming from the sun. Mercury is the closest planet to the big guy, but Venus is still the hottest. This tiny planet needs 1,408 hours to finish an entire day, which is around 60 Earth days. It's a good thing you arrived during sunset. You have an epic view of the sunset, and as soon as the sun is completely gone, it gets really cold. Since Mercury doesn't have an atmosphere to trap heat, the cold takes over quickly, so you hibernate for a whole month before leaving. You arrive at Saturn, the ringed planet, and see the giant moons orbiting around it. Saturn only has 11 hours in a day. This planet is also extremely windy in the upper atmosphere. And on top of the fantastic view of the moons, you can't miss out on the rings. They're made out of ice and rock particles, ranging in all sizes from a grain of rice to the size of a boat. Billions of these particles are floating in the air, which scientists believe to be the remains of comets and dwarf planets. Next, you travel to Titan, Saturn's largest moon and the second largest moon in the solar system. According to scientists, Titan has the closest Earth-like conditions. It's just colder since it's further from the sun. Besides Earth, Titan is the only place in the solar system with liquid lakes, rivers, and oceans. Methane and ethane lakes are all over the place, so you get on a fabulous cruise around this moon. The atmosphere is also similar to that of Earth and has the right ingredients to start life. You look up at the sky and see clouds forming as it begins to rain. You hide under the shady part of the boat and wait for it to settle. Titan has a methane hydrological cycle pretty similar to the water cycle on Earth, meaning water first evaporates into the sky and then it starts raining. After the fantastic cruise tour, you go to some of the other moons and eventually back to Saturn. You're looking through all the pictures you took as you head back to Earth. The whole trip took you almost an entire Earth year, and your body just can't adjust to Earth's conditions anymore. You were so used to sleeping and waking up in total darkness, and in some places, exposed to extreme sunlight. You've slept in different places with different gravity levels, so you don't know what it feels like to sleep on an actual bed anymore. In some areas, you were placed in upright sleeping pods to accommodate for the lack of space. As a result, you're getting constant headaches and keep waking up in the middle of the night, forgetting where you are. Also, you were lighter than you are now for most of the trip, so you lost some muscle mass when you came back to Earth. There are some nights where you don't even sleep and wait for the sun to rise, just like you'd see on Saturn or Jupiter. As a result, your sleep cycles got messed up. Life on Earth got way harder for you after such a trip. So you decide to hibernate for some time to adjust back to our planet's conditions, just like you did on Mercury. When you explode planets, things get red hot. Atmospheres are stripped away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Some time before the explosion, you're hovering in almost complete darkness. Below, you see the moon, or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury, and right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart. And then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. The appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume. And finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, it knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains, covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1,600 of them. Unfortunately, you won't be able to do that because you press the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust. Then you spot bright burning meteors flying towards you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 1,200 miles thick. But that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach the blue marble of your home planet. What will its insides look like, scattered in space? From above, Earth looks pretty. 71% of its surface is blue because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume. You see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area, but in most places, it's 7 feet thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then the flying pieces get solid again. Ah, it's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 degrees Fahrenheit. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core, 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong, it evaporates smaller planets like Mars and Earth. The Sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful: gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water, ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of the ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way, Neptune. It looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why, after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and other metals.
The planet races through space. Its orbit is unstable, like a pool ball gliding across the table looking for a target to collide into. Only this ball is the size of Mars, and it's going 9,000 miles per hour. Boom! It crashes into another planet. This Mars-sized object was called Theia, and what it smashed into was Earth. The impact released 100 million times more energy than the asteroid that wiped out the dinosaurs. The planetary collision threw tons of solid material from both objects out into space. But only one of the bodies survived. Theia was obliterated and then swallowed entirely by early Earth. But that debris didn't go flying endlessly into the cosmic void. No, something crucial happened. All those solid chunks gathered into a cloud. Gravity squished it together, pressing more and more. And in the end, our moon was born. So goes the theory. At the time of the impact, the solar system was just forming, and this rendezvous of epic proportions probably wouldn't have happened if it weren't for a newly formed Jupiter throwing Theia off its orbit and straight into Earth. Our young planet withstood the blow. Time passed. Earth evolved. Its surface will become unrecognizable over the next 4.5 billion years. It's hard for the human mind to understand this vast amount of time, so we'll squeeze it all into one day. If midnight is when Earth first formed from gas and dust that remained after the Sun's creation, the next 4 hours show a lifeless planet. Red-hot, covered in lava, constantly bombarded by asteroids and, as you know by now, even a whole other planet. Yet life finds a way. The first cells appear. It's 4 a.m. on the clock. At 2:08 p.m., we see the first single-celled organisms form. It's not until 8:28 p.m. that sea plants appear. 20 minutes later, what's this? Jellyfish. After them, the planet flourishes with different fish, reptiles, insects. The forests grow at 10:30 p.m. Between 10:56 and 11:40, dinosaurs roamed the Earth. The giant lizards ruled our planet for less than 1 hour. A minute before the dinosaurs' extinction at 11:39 p.m., the first mammals begin to run around the planet. At 11:58 and 43 seconds, humans appear. In the cosmic scale of things, we've only ruled this planet for 1 minute and 17 seconds. So here's the main question baffling scientists. Why didn't life on Earth ever stop? It had every chance to cease. Why didn't our planet become like Venus or Mars? They both once had an atmosphere and oceans. Today, they're lifeless deserts. Forget about complex scientific concepts and theories of the universe's structure. Our little rock and all its inhabitants are just incredibly lucky. Professor Toby Tyrrell at the University of Southampton used computer programs and climate simulations to solve the puzzle of why asteroid collisions in ice ages didn't turn our little rock into a lifeless wasteland. The research team took not 10, 100, or 1,000 virtual planets similar to Earth. They used 100,000 for the experiment. And every single one of those 100,000 were simulated 100 times. They exposed these virtual planets to different phenomena. They were bombarded by asteroids, frozen, exposed to epic eruptions of supervolcanoes that blacken the skies and block the surface from the sun's rays. Just 9%, or 8,700 of them, were successful one time in 100 simulations. Of that group, 4,500 planets remain inhabited 10 times. Only on one planet out of 100,000, life didn't stop all 100 times. If life is a lottery, Earth got extremely lucky. In 2009, the unique Kepler telescope was launched into space. Its task? Search one patch of the night sky, or 150,000 stars, for rocky Earth-like planets. Over 9 years in service, it ended up surveying more than 500,000 stars. In all that time, with all those observations over nearly a decade, Kepler discovered 2,600 possible Earth-like planets. The weird thing is, most of them are a type you can't find in our own solar system. They're something between the size of Earth and Neptune. But back to the real Earth. If you go far from the city and look up at the sky, you'll see an ocean of stars. If you're lucky and it's a clear night, with an unaided eye, you could count a maximum of 2,500 points of light. Yet, there are at least 100 billion stars in the Milky Way. Some estimates put the numbers of stars in the Milky Way up to 400 billion. So, where's this giant range coming from? Well, counting stars isn't exactly an easy job. Scientists obviously don't number each one individually, 1, 2, 3, and so on. You know how long it takes to count just 1 billion? Over 100 years. Now, multiply that by 400. Instead, they look at small patches of space and use some complex scientific formulas to make educated guesses of how many stars there are in total. You can do a similar experiment yourself. Imagine a bucket filled with 10 pounds of rock, sand, soil, and other items. Your job? Understand how many rocks are in that mix. We'll count only those rocks that are visible to us from above. Get a rough estimate of their volume and weight, what percentage of the total we can see, and with some calculation, you can get a number. Is it exact? Nah. Why? Because you can't know if the rocks in the bucket are spread evenly throughout, or if they're all about the same size throughout. What if the ones at the bottom, if there are any, are bigger or smaller than your sample view? They could have completely different weights and volumes. That bucket is our Milky Way galaxy, and the rocks you are counting are stars. The point? Scientists can't know for sure how many stars there really are. Maybe 100 billion, or perhaps 4 times that. Of those, 4 billion are like our Sun. With our own galaxy, the most accepted estimate for planets that could potentially support life is 300 million. Though, as the tradition of scientific inexactness goes, that number could be up to 5 billion or more. Either way, lots of real estate to choose from. And that's just the Milky Way. But get this, it's just one of 200 billion galaxies in the observable universe. The most recent research puts that number 10 times higher, something like trillions of galaxies in space. And we've only studied less than 10% of them. As for how many stars there are in the universe, scientists put it at 1 septillion. That's 1 followed by 24 zeros. Again, it's all estimates because we can't know for sure. So far, one thing is clear. Our Earth is the only place in the universe that we know of where there's life. And this planet has done everything it can to change that. Over the past 540 million years, more than 20 major extinction events have occurred. The last one was 66 million years ago. Yep, it was the one that took out the dinosaurs, and 75% of all life on this planet for that matter. An object 7 miles across in diameter smashed into our planet. It was going 120 times faster than the fastest car today. Over 900,000 miles all around the impact site, everything caught fire. A huge tsunami swept across the world's oceans. Billions of tons of dust and sulfur rose into the sky and blocked the sun's warm rays. A global cooling came to Earth. A little over 200 million years ago, there was a lesser-known extinction event that wiped out half of all life on the planet. Most likely volcanoes or an asteroid strike are to blame. Other theories say the movement of tectonic plates triggered another ice age. At that time, huge crocodiles ruled the Earth. They disappeared and new animals entered the arena of history, dinosaurs. But the worst this planet has ever seen was the Permian Triassic event about 250 million years ago. 80% of marine life, 70% of land animals and plants, all gone. Volcanoes spewed out a colossal amount of lava where modern-day Siberia is, but it affected the entire planet. Around 445 million years ago, the dominant life form on our planet was marine invertebrates. There was only one continent, Gondwana, and plants were just starting to flourish on land. But something happened that took out 75 to 85% of all living organisms. It could have been an ice age, rising temperatures, or a more daring theory. Some think it could have been a huge star exploding 6,000 light-years from Earth. It launched a jet-like gamma-ray burst that ripped across space, and poor little Earth happened to be in its path. It burned off the ozone layer instantly. Yeah, we kinda need that thing to protect us. Case in point, no matter how much this planet, or even the universe, tries to wipe out life on Earth, which is here in the first place from unbelievable odds, life always finds a way.
More than 1 million Earths can fit in our sun. New research shows that between 20% to 35% of suns eat their own planets, and a quarter of planetary systems orbiting stars like the sun had a chaotic past. The very thing that gives life can also take it away. All the planets in our solar system revolve around the sun, and they all do it in a somewhat consistent way. It's most likely that they stayed that way ever since they first came into the picture, but not all of them. This chaotic existence means that a solar system had a lot of planets in the litter until the host sun decided to melt them away. Our solar system is panned out perfectly so that no planet's gravity interferes with each other. The gravitational force on Jupiter is a lot tougher than Earth's, which means that if Earth gets close to Jupiter, we'd be another moon for Jupiter. The planet is so big that if Earth were the size of a grape, Jupiter would be the size of a basketball compared to it. Even with the best technology in the world, it's difficult to tell if stars do, in fact, eat their planets. The best way to study this is to observe binary systems. That's just a sciencey way of saying a system with two stars orbiting each other. Usually, the two stars were formed around the same time from the same gases and the same conditions. It means they should contain the same elements, more or less. When you open your eyes in the morning, the sunlight that's been traveling for millions of miles greets you. The closer we get to it, the hotter it is. But the rays traveling from the sun also contain certain chemicals that make it unique. The chemicals that are associated with the sun are light materials like oxygen, carbon, hydrogen, and helium. You can find some other stuff in it too, but these are the main ones. By studying these elements, you can learn the history of a solar system with enough detail to determine if it was chaotic or smooth. Scientists studied 107 binary systems composed of suns like ours by analyzing the light. Since each system contains two suns, they compared and contrasted them to see the differences. They observed the stars with a thin outer layer, having different elements than their companion. All suns contain light elements, but there are some that have rocky elements, like iron, silicon, and titanium near the sun. These elements are associated with rough terrains that you'd find on the surface, but they're out there floating in the middle of space. The thinnest outer layer is especially rich in iron compared to the other layers. Many stars are twins at birth. Even most of the Milky Way stars have a buddy in a binary system. It means our sun is pretty unique for not having a partner. But there are some theories out there that suggest that the sun may have lost its twin in the past. It's around 184 light-years away and is called HD 186302. This might be our lucky star. A stellar nursery is where thousands of stars are born. They're made up of gas and dust that gradually collapse under their own weight. Our sun may have started in such a way 4.6 billion years ago. And when they're mature enough, they go out into the open, usually with their travel buddy. Actually, scientists claim that up to 85% of all stars could be in binary pairs or have more buddies, but over 50% are dual pairs. The only problem is that we can't really see it, since it strayed from its original orbit an eternity ago. but traces of it can be found in the Oort cloud. That's the vast cluster of space consisting of comets, space rocks, and ice in the outer edges of our sun's reach. They float around quite a lot since they're far off the sun's gravity and can easily be knocked out of their orbit into open space. Flying through such a space is no different than flying through any random void of space. The reason why some of these light elements in space contain rock elements you'd find on the surface of a planet is because the sun knocked them off their orbit and devoured them as they got closer. It also happens when a star becomes too big in its place and starts eating everything around it. According to scientists, if a star eats a planet, it can make it go chaotic and spin so quickly that it eventually rips apart. But don't worry, there's a very low chance of the sun devouring the planet in the near future. Stars are formed when a huge cloud of hydrogen and helium grows until it collapses under its own weight. The pressure increases and reaches extreme heat levels we can't even measure. Eventually, the hydrogen atoms lose their electrons, causing the hydrogen to fuse together and release energy, countering the gravity collapsing. But when the gravitational force overpowers the hydrogen fusion, the star begins to expand and becomes a red giant. And then, after around 1 billion years, the hydrogen in the outer core will go away, leaving plenty of helium hanging around, which will fuse with the rest of the elements around. And once all the helium disappears, gravity will shrink the red giant into a white dwarf. And when it's completely gone, the remains of the star release tons of gas and dust into space. Scientists claim that our sun has between 7 to 8 billion years left before it reaches that stage. But even if that becomes a reality, it wouldn't happen overnight. Something like this takes millions of years to take place. But what if the sun decided to devour us overnight as we speak? The planet would start feeling hot in seconds. Every slight degree change can lead to some catastrophic events. Ice caps can melt in a matter of seconds and flood the coastal lands. Even little islands in remote areas of the world will be submerged. And as it gets hotter, every snow-capped area will melt instantly and turn into desert-like climates. Some places will burn, and your everyday objects will melt on the spot. The Earth's interior will also get hotter, allowing volcanic eruptions to happen across the world. Antarctica will melt from the heat, as well as the volcanoes erupting inside. And just in a matter of minutes, the whole planet will turn into fire and ash before it explodes into tiny bits floating in space, reaching areas we've never even heard of. But no worries, something like this won't really happen. In case the sun knocks us off our rotation, the results would be different. It'll also get hot because the magnetic field around us protects us from the sun's radiation. And once we get knocked out of place, the magnetic field gets tarnished, and the extreme heat from the sun will boil us. The gravitational force will be unstable, so the physics of our everyday life will be chaotic. We'll have to wait 5 billion years from now when the sun turns into a red giant. It'll grow in size, eventually eating up Mercury and Venus. Chances are, Earth will also be on the menu. If Earth were to move only 900,000 miles closer to the sun, then it would be uninhabitable. It may seem like a lot, but it's only 4 times the distance between the Moon and Earth. Detecting the chemical composition of the sun rays in solar systems that are further away could help scientists find other Earth-like planets. Since the atmosphere around these planet-eating stars changes the chemical composition, we can detect which solar systems out there have had a calm past. The main thing we have to observe is if the planets have a healthy orbit cycle. With nothing else getting in the way, we can assume that the planet could follow the same steps as Earth did for humans to be here. But this process will take ages, since there are millions of nearby stars similar to our sun. The odds of finding a planet similar to ours are near impossible at this rate. But if so, then there might be life on those planets. There will be no way of knowing if it's intelligent life, but they might have had the same evolutionary fate as us.